Hey, Math 8, welcome back. Today we are starting Chapter 6. And listen, in my opinion, what we're starting today is probably the most important section that will help you next year in Math 1. Maybe second to solving equations. Solving equations is a really important topic. But what we start today is equally important going forward into next year. So I hope you'll take good notes, and I hope you'll ask questions if you have them, and let's get started. So today, you can see the objective today is to understand, there we go, what makes a situation linear. And by a situation, we're going to talk about tables and graphs and equations and situations. And we want to know what makes them linear. And specifically today, we are going to learn how to model a situation with a linear equation. All right? I don't think you'll find it that difficult. I've tried to break this into easy steps. If you will just follow along day by day, I think you'll have success. All right, so today, well, I'm going to give you an overview first. We are going to look at what it means to be linear on a graph, in a table, and an equation. And we're going to spend several days on that. We will then learn to model a linear situation with a mathematical equation. And this is specifically what we're going to do today. But first, I'm going to look at what it means to be linear. And then we will talk about modeling a situation. All right, so linear situations have two things in common. They all have two things in common. Do you know what they are? They all have a beginning amount. All linear situations start somewhere. We call it the beginning amount. And they all increase / decrease by the same amount each time. All right? They have a beginning amount, and they either increase or decrease by the same amount each time. That's what makes them linear. Those are two things that all linear situations have in common. By the way, please stick around for the 4 examples I'm going to do, because each example has a special situation that I think I want you to see. It'll help you with your work. All right, so what I want you to see is what a linear situation looks like on a graph, in a table, or in an equation, right? And we're going to start with a graph. And I'm just going to make up a linear situation. And I've taken the liberty of already kind of filling out the graph. Down here, I have months. So that in a graph, that is the x-axis, and the x will be representing months. And this is the y-axis, and it will be representing dollars. And perhaps this is how much money maybe somebody has in the bank. That's supposed to be a B, whatever. And I've already kind of scaled the graph for you. And so just making this up, so after 0 months, maybe they have, how much would that be, do you know? Well, it would be, let's see, 4 lines is 1,000. So it looks like if 4 lines is 1,000, every line would be $250. So it looks like after 0 months, $750 in the bank. That would be like the starting amount. They're starting with $750. It's been 0 months, and that's how much they have. Right? And then maybe 1 month later, they're up to here. Maybe they put $500 in the bank, right? And now they're up to $1,250, right? So every line is $250. They just went up $500. And every month they go up $500. See how that works? And so look at those points. If they start at 750, if 750 is their beginning amount, and they go up the same amount every time, $500, then this situation is linear. And what does it mean to be linear? It means on a graph, it makes a line, right? The word line is right there in the word linear. It means it makes a line, right? If they went up by different amounts each time, like let's say they start at 750 and they put 250 in the bank, and then they put 500 in the bank, and maybe the next month they saved a lot. They saved $750. So that would actually be a curve. And in math, when it curves, it is not a line. A line, by definition, is straight. In math, the green one is not a line. It is actually called a curve. All right, so we don't want the green one. I just wanted to show you the difference between a line and something that's not a line. So there's our line. All right, what about a table? So a table is a way to name ordered pairs that are on a graph. And let's do this in blue. I'm going to name each of these ordered pairs that I made in a table. We've kind of done this already. Right? So my X in my table stands for months, and my Y stands for dollars in the bank. And if I were to name these, right, these 5 ordered pairs, right, 0, 750. That would be my first ordered pair, right? That's right there. And then I've got 1, and that's 1,250. And then I've got 2, and that's 2,750. And I've got 3, and that's 2,250. And I've got 4, and 4 is at 2,750. Now, how can you tell the table is linear? Well, you can tell the table is linear because it goes up by the same amount every time, right? There's a starting amount, and then it's increasing by 500 each time. That's what makes it linear, that it is increasing by the same amount each time. All right, and last up we have the equation. Now the equation is probably the best thing to eventually totally understand. We're going to start pretty easy, I'm hoping. So all equations look like this. This is like the formula for a linear equation. All linear equations can be written in this formula. And these letters, they stand for something. The B stands for the beginning amount. That is what the B stands for in this formula. And the M stands for the amount of increase each time. That is what the M stands for. And so if you know the beginning amount and you know the amount of increase, like we do in this situation, right? The beginning amount, let's go back to green. The beginning amount was right here. It was $750. And I was going up by let's put this in red. I was increasing by $500 each time. So the equation here would simply be y equals the beginning amount plus how much it goes up each time, that's the m, times x. All right, and all I did was I put the beginning amount in place of the b, and I put the amount it increases each time in place of the m in my little formula there. And I have now written an equation. Now, there are two things I think you should know about the equation. All right, one thing is that the x and the y, they stay in the equation. And I think you should be able to tell what they represent. Like in this case, we kind of already did it over here. The x represents months. And the y represents dollars in the bank, right? And the x and the y remain as variables in the equation. Now, the second thing is, why do we want an equation? We want an equation so we can make predictions about a situation. For instance, maybe this person wants to know how much money they will have in the bank in 3 years. Maybe they're saving up for a car, and they want to know how much they're going to have in the bank in 3 years. So what they could do is they could now use their equation to calculate that. 3 years is 36 months. So they could say, well, I started with $750 and I'm adding $500 for 36 months. And they replace the x, which is how many months, with 36. And then by doing the arithmetic, they can calculate how much they will have after 36 months. So that would be 750 plus 500 times 36, and they would have $18,750. They can afford to buy a pretty good car for that, right? All right, so one more thing here. How do we tell if a graph is linear? It makes a line. How do we tell if a table is linear? It increases by the same amount each time. And the equation, I'm going to say one thing for now. Here's the thing about the equation. It is linear if it has no exponents. Please write that down. If there are no exponents on the variables, it's a linear equation. All right, we are going to look at next, how do we take a situation and write a linear equation to model it? Well, I've given you 3 steps here, pretty quick and easy, frankly. First, you want to identify the 2 key elements of every linear situation. What is the beginning amount? And what is the amount of increase or decrease each time? And if you can answer those 2 things, it's so easy to write a linear equation. Right? All we're going to do is we're going to use the formula y equals the beginning amount plus the amount of increase each time times x. Now, I always use x and y, but sometimes you do not have to, ever. All right, so step 2 is to use the formula, and step 3 is substitute the beginning amount in for b, and substitute the amount of increase or decrease in for M. And my last little note is you should be able to identify what the variable x and the variable y represent in your equation. All right, here we go. We're going to do 4 examples and we'll be done. So the first example says Braden is ordering a taxi from an online taxi service. The taxi charges $2 just for the pickup and then an additional $1.50 per mile driven. How much would a taxi ride cost that is X miles long? So I wrote this on purpose so that it is like the Delta math questions. How much would a taxi ride cost that is X miles long is like asking you, model the situation with an equation. I'll show you how it's the same. All right? When they say, well, let me get to it. So the beginning amount, we need 2 things here. We need the beginning amount. And before I go anywhere in this taxi, I have to give the guy $2. $2 is the beginning amount before I drive anywhere. That represents the charge just to have him come pick me up. And then this one is going to be an increase, right? And it increases $1.50, per mile. That is the amount that it goes up each time. So my equation, now let's see, y equals b plus mx. So my equation would be y equals, I'd put the beginning amount in, which is 2. And the amount it goes up each time is $1.50. It's per mile, right? That per mile means $1.50 times X. X is the number of miles you drive. And you've written the equation. That's all there is to it. One last thing here. I would like you to be able to identify, right? Identify the X variable and the Y variable. Oops. So let's do that. So the Y here is the cost for the taxi, and the X is the number of miles I drive. It's $1.50 times the number of miles I drive, right? Could have got that right here too. All right, that is a very basic example. Let's go to example 2. Dana is driving on a long road trip. She currently has 13 gallons of gas in her car. Each hour that she drives, her car uses up 1.25 gallons of gas. How much gas would be left after 8 hours? Now again, when it uses a variable like that, it's really asking you to model this with an equation. And I'll get back to that. And how much gas would be left after driving for 7 hours? Okay, so again, I need the beginning amount. Do you see the beginning amount? So the beginning amount is right here. 13 gallons of gas is how much she has right now at the beginning. And this one is actually using gas. The amount of gas she has is going down, so it's a decrease. And it's decreasing by 1.25. Looks like, let's see, each hour, 1.25 gallons per hour is how much it's decreasing by. All right, so my equation would be, let's see, right? I'm going to use my same formula here, b plus mx. Didn't do a very good plus sign there. And my beginning amount is 13. Now, I'm not adding to my beginning amount this time, right? I'm subtracting because it's going down. So when it's decreasing, you're going to want to subtract. And how much are we subtracting? 1.25 for each hour, per hour. So That would be times X. Or, you know what? They told me to use H. So, instead of X, I'm going to use H. That's okay. A lot of people like to use a variable that is like the first letter of what it represents. So in this case, the H represents hours, and the Y represents how many gallons are left in her tank. Gallons left. All right, this problem asked an additional question. They asked how much gas would be left after driving for 7 hours. All right, so I can use my equation, and on your homework, you'll have to use the equation to make a prediction. How much gas will she have after driving for 7 hours? So we're just going to take 7 hours and put that in for H. And by putting the 7 in place of the H, I can now calculate the Y value, which is how many gallons she will have left when H is 7. And I would get out my handy-dandy little calculator, and I would find out that that is 13 minus, 7 and 8.75. And when I subtract that, I get 4.25. She will have 4.25 gallons left after 7 hours. All right. 2 more examples and we're done, you guys. This is a tricky one. Here we go. Nicole works in a department store selling clothing. She makes a guaranteed salary of $200 per week, but is paid a commission on top of her salary equal to 15% of her total sales for the week. How much would Nicole make in a week if she had X dollars in sales? Okay, so here it wants me to write an equation using X. All right, so the beginning amount, she makes $200. That's the beginning amount. She always makes $200. Plus, she could make some more. How much can she increase? Now, this is a tricky one in this case. She increases by 15% of her total sales. So 15% of total sales. Now, this is why I wanted you to see this one. I want you to see that X is her dollars in sales. So this is really 15% of X. That's how much she increases by each time. All right, that's one thing. So the second thing I want you to see is this. It wants us, let me go back and say this again. It wants us to write an equation. How much would Nicole make in a week if she had X dollars in sales? So right here, we want her earnings when selling X dollars. Okay, when you do this on Delta Math, they are not going to have you write Y equals. They're just going to have you write what comes after the Y equals. This, how much she makes, this is the Y value. And how much does she make? Well, her beginning amount plus the amount she goes up each time. So in this case, it would be 200 plus 15%. To write 15%, you'd have to write 0.15. If you type in 15 on your calculator and hit the percent button, it'll tell you that's 0.15 if you're not good with percents from last year. And then the X. This is how much she would make. Notice you do not type in the Y equals, even though it's really there. And so, this one also asks us an additional question. How much would Nicole make in a week if she had $225 in sales? Well, X represents her dollars in sales. So I can calculate how much she would make by putting in $225 for the sales and doing the calculations. And that would be 200 plus 0.15 times 225, 233.75. That is how much she would make. All right, last example. Molly went to the store to buy some chicken. Okay, this has one tricky thing in it and we're done. The price per pound of the chicken is $3.50 per pound, and she has a coupon for $2.50 off the final amount. With the coupon, how much would Molly have to pay for P pounds of chicken? Okay, so the beginning amount, well, if she doesn't buy any chicken, you'd think the beginning amount would be zero, right? It'd be zero. But she gets $2.50 off the final amount. So this is what I want to point out to you. Her beginning amount is actually negative $2.50. And she's going to increase by, for every pound she buys, the price goes up by $3.50. So it's increasing by $3.50, right, per pound. That's how much it's increasing by. So what is the cost of P pounds? Remember, this is like your Y equals, and on Delta Math, you will not be typing that in. But Y equals, or the cost equals, the beginning amount plus the amount it goes up each time. So the beginning amount is negative $2.50 plus $3.50 times X. And what does X represent in this situation? X represents the number of pounds that she buys. It's $3.50 per pound. All right, I hope that gets you going on the homework. I don't think it'll be too hard, I'm hoping. Let me know if you have questions, and I'll see you guys later.